Bismillah ar-Rahman ar-Rahim. I'm Muhammad Imran and I'm here to teach you CPCS 371, which is the first course in computer networks in computer science department. So let's start with our course Computer Networks 1, CPCS 371. Our course book is Computer Networking Top-Down Approach by Rose. It is 5th edition. Okay, these are the author slides which I am following. So let's have the introduction of the course. This is the first course in the computer science, computer networks specialization area, and this is the course in which you will be given introduction about the OSI 7 layers step by step and all the protocols which will be used in the computer networks on different layers will be taught to you, and how the computer networks behave, how they look like they are. Okay, so let's start with chapter number 1, which is introduction. Lecture number 1. I will be following the author slides. It will be available on the Moodle as well. What is our goal in this course? Get feel and terminology. Feel how you are working on the network and start thinking that why it is like this, what terminologies you are using and how it behaves when you work on a network. Then slowly we will start going into more depth when we will go later in the detail in this course. The approach which we will use, it will be use of the internet as an example. We will use different applications, network applications from the internet. Okay, and we will keep on explaining you while we proceed in the course. Overview of this chapter is what is internet, what's a protocol, okay, what are the network edge devices, what are the hosts, access net, physical medias, different type of physical medias which we are going to study in this course. What is the network core, what devices are being used at the core, what is packet and circuit switching, okay, what is the internet structure, how it is built. Okay, we will look into the performance of the network, what are the losses and how to handle them, how the delay will affect the performance of the network and the throughput, security, protocol layers, service models, and bit about the history. Start with the first topic, what is internet? Okay, because nowadays everybody is using internet. What is the simplest definition of the internet? If we look into it, the simplest definition of the internet is internet is a network of networks. Simplest definition of the internet is a network of networks. So many networks. If we take an example of this lab has, for example, 30 computers. It is a local area network inside this lab. Similarly, like this, there is another lab in the adjacent room, and then after that there is another lab. So if you connect all these labs together on the ground floor, on the first floor, on the second floor, you could say that it is FCIT, local area network. Same like this, you connect another faculty network with this one and keep on connecting all the faculties network together. Finally you will call it KAU network. So ultimately, what is the objective? You have to connect the KAU network with the service provider, for example STC or Mobile, to get the internet service. So by this way you will be connected to the internet. You will become part of the internet. So the biggest network is the internet, and you are internet, and you are going to connect your network into this network. Ultimately it will become a bigger network. So internet is a network in which so many networks. So KU network is one of those networks which are being connected into the internet. Clear? We will have further details about the internet in the following slides. Look here now on the slide, lecture slide. What is internet? These are the nuts and bolts of the internet. This is the view of the internet from nut and bolt point of view. That with what are the things which with we can say that internet is built up. Okay. You are using everyday mobile phone while you are roaming or while you are moving in your car on the move. Okay, and you are connected through the cellular tower to the mobile network. Okay, so this is your, as a whole, this is your mobile network. In the home you are using your home network. Okay, you are connecting your laptop or your desktop computer with the router which you have got from the service provider. Okay, same like in your institution, you have a LAN in one building. Okay, that is connected with your router, another LAN in the same building, and that router is connected with another router, further with another router, and this router is having a server farm here in which you have the servers which are going to give you services. Okay, then you have an access point connected with the router, and through this wireless access point, Wi-Fi access point, your mobile devices, for example your laptops, your PDAs, your notepads, are getting the Wi-Fi service. Okay, wireless internet. Ultimately this institutional network, for example the KAU network, you have to connect with the service provider router. Same like your home network, you have to connect your service provider router, internet service provider. This is the regional internet service provider. Regional internet service provider gets the services from the global ISP. Okay, you could say that global ISP is the ISP which is giving service to your regional ISPs. Okay, and further regional ISPs are giving services, internet services, to the companies, institutions, universities, home subscribers. Okay, so ultimately you have connected your mobile network, your home network, your institutional network into the regional and the global service providers. Okay, and all these networks are connected together with the regional or the global ISP. Like this, in one area and in all the areas, other areas, in one city, in all the cities, in a country, in multiple countries, ultimately it will be connected and they will form a bigger network, and that bigger, rather we should say biggest network, and that will be called the internet. Clear? So these are the devices and are called the end systems or the host systems. So millions of connected computing devices, for example this mobile phone, this laptop, desktop computers, mobile servers, these are the end devices, end systems. These are called the host systems. So million of computers are connected, or million of end systems or host systems are connected with the internet. And what they are running? They are running the network applications. For example, you are using a Skype, MSN Messenger, internet browser, Google Chrome or Firefox. Okay, all these are network applications which you are running on these hosts. This is the PC, this is the symbol for the server, this is the symbol for the laptop and mobile phone. Cellular handheld devices or mobile phones or cellular phones. This is the symbol for the access point. This is the symbol for the cellular tower. Either you are going to connect your desktop computers through a wired link into the router, or your laptop through a wireless link into an access point. So you do need an access point or a wired link. So this is a wired link. Okay, this is an access point to connect your laptop, mobile phones if they are using the Wi-Fi, and this cellular tower is used to connect your mobile phone with the mobile network if you are using on your mobile phone the cellular service, because both the services you can use on your mobile phone, Wi-Fi as well as cellular service. So you do need a communication link in order to connect your end systems into the network. Those links can be either optical fiber cable, copper cable, radio link, a satellite link. Okay. Now you have to take care of the transmission rate, the band width, which you do need in order to use your applications over that network. So bandwidth is basically measured in the data rate, that what data rate you are getting. Okay, that is called your transmission rate. Bandwidth is the width of the band of the frequencies on which you are getting a particular data rate. How you get the bandwidth? If you have the highest frequency, okay, highest frequency minus lowest frequency, you will get the band width of that link or of that channel on which you are getting the service from the service provider. Now on that particular channel, it depends either it is being shared or it is dedicated, whether that channel is shared or dedicated. If it is shared, you will get the whole bandwidth. If it is dedicated, you will get share of it, partial. This shared, usually home users, home subscribers, they get the shared bandwidth, and the dedicated, the enterprise or the companies, they get the dedicated one. They go for the dedicated one because its charges are more, and here the charges are less, the cost is less. That is why you go for the share in the home users. Yes.
What do you mean by shared? It's called
Shared, no, sorry, the shared will not get whole, it will get share of it. Share of it. Thanks. And the dedicated will get the whole. Sorry. The dedicated will get the whole pipe, and the shared will get the share of it. For example, this is the pipe, this is the bandwidth, okay, highest frequency minus the lowest frequency, this is your bandwidth, okay. Now if it is shared among 4 users, user 1, 2, 3, 4, okay. For example, if it is 8 Mbps, 8 megabits per second, now each user will get 2 Mbps. Why? Because 8 divided by 4 is equal to 2 Mbps. Clear? So this is shared. Dedicated mean you have the whole 8 Mbps data rate, okay. Whole, this is the transmission data rate which you are getting on this pipe, on this link, on this channel. So 8 megabits per second mean you are getting the whole 8 megabits per second here, the single user. This is the dedicated. This is the shared. Multiple users are sharing the channel and they are getting the share of it. The share depends upon the number of the users. that how many users are going to this pipe, how many users are going to share this pipe. Okay, and here the dedicated mean it is only for one user, the whole bandwidth will be utilized by single company. Okay, and here it will be shared among multiple users. Clear?
For the channel, what is the maximum bandwidth that it can handle?
The channel, it depends upon the highest and the lowest frequency. If you subtract the highest from the highest, the lowest one, you will get the width of the band. For example, if the highest frequency is 1800 megahertz and the lowest is 900 megahertz, what will be the difference? 1800 megahertz minus 900 megahertz, so you will get 900 megahertz. This is the frequency, okay, of this channel. On this channel, you will, when you transmit the data, definitely you will have the transmission rate. That will be your data rate. Okay. So you could have different type of channels, communication links, either optical fiber, copper wire. Okay, it could be coaxial cable or the category 5, 6 Ethernet cable. It could be a radio link, satellite link, and the transmission rate will depend upon your bandwidth and how that channel is being utilized, whether it is shared or dedicated. Clear? Then further, you do need the routers to forward the packets on the network. For example, you have seen here one router in the mobile network, one router in the home network, one router in the institutional network. These routers are called the gateway routers. This is the point from where the traffic for this particular network either leaves the network or it enters into this network. So this is called your gateway router. Okay. So routers are used to forward the packets, chunk of data over the network. Your gateway routers are connected into the service provider routers, and service provider could have many routers and they are connected with each other in order to form the redundant links. Okay. There are so many cool internet appliances. For example, you have IP picture frame in which you can see the pictures taken from your IP cameras and can be randomly sequentially played over the IP picture frame. This is the smallest web server. Okay, you can get its further information from here. Then you have the internet phones, IP telephones, which are being used over the internet. Further, you can have voice communication and video communication on it as well, because IP phones can carry your voice and video at the same time, and you can connect your computer with them as well. Web-enabled toasters to get weather forecast, whether how will be the weather, either it will be sunny or cloudy. Okay, this slide shows you a part of the internet. Do we need some protocols or rules in order to send or receive messages over the network? For example, I am delivering a lecture here. All the students are listening and the lecturer is delivering the lecture. If you want to ask any question, you will raise your hand and turn by turn you will be asked questions. Okay, what is your question? And the teacher will reply you. This is a rule, a protocol when the teacher is delivering a lecture in the class. Similarly, over the network, when two end systems or hosts, they want to communicate with each other, they should follow some protocols in order to communicate with each other. So protocols are used basically to control the sending and receiving of the messages between the hosts over the network. Examples of the protocols are transmission control protocol, internet protocol, hyper text transfer protocol, Skype, Ethernet. So these are different protocols which are used on the OSI layers, on different layers, and we will have a detailed study of these protocols when we proceed further in this course. Internet, as I already have said you, is a network of networks. Loosely hierarchical mean that these networks are connected with one another in some hierarchical order, but this is not a strict order because the topologies which are used in every network are different. So that is why they are called loosely hierarchical networks. We have public internet versus private internet. Private intranet is the intranet of an organization or of an institution. For example, we do have 3 branches. We can connect 3 branches together. For example, this is our Sulemania branch, this is Faisilia branch, this is Shumal Jadda branch. So all the 2 branches are connected with the head office, and head office is further connected to the internet. So this is the private intranet of the institution, of the university, for example. And public internet is that with which you connect your private intranet to get the internet service. Public internet is not secure. Private intranet, you do need its security because public internet is being used by every individual, and private intranet is only used by your own company. So you have to make sure about the security of your private intranet. Only the authorized persons should be allowed to enter into your private intranet. Internet standards, the bodies who are responsible to form the standards for the internet are different bodies. One of the body for the internet standards is called Internet Engineering Task Force. Okay. Whenever you want to make any research work published and then further you want to declare it that it should be declared as a standard, you put it on the RFC website, request for comments website, where the people, the researchers from the world, they have a look into it and they comment on. You have requested to comment on your research work, and they will comment on your research. If it is approved by the Internet Engineering Task Force, it could become a standard for the internet. If we look on the internet from service point of view, we have to take care of communication infrastructure which enables distributed application. For example, web applications, voice over IP application, email, games, e-commerce, file sharing. These are those applications which are distributed over the network. Voice over IP communication, one party is on one end and the other party is on the other end, and they want to communicate with each other. We are exchanging daily emails with the other people who are sitting in any part of the world. Online games we are playing, we are having a lot of websites on which we are doing the e-commerce, we are sharing the files. So all these are called the distributed applications, and this is only possible with the help of communication infrastructure. If there is no communication infrastructure, how we can have a communication between the applications which are distributed apart on the internet? Communication services are provided to the application, and these communication services should be the reliable data delivery starting from the source to the destination and back from the destination to the source when the reply comes back. Reliability is the very important factor on the communication. When you communicate something, you should be assured of it that your data has been delivered from source to destination reliably. Best effort delivery means we are not calling it a reliable service, rather we could call it unreliable data delivery, but it has to be immediately delivered to the destination from the source. So it depends on the nature of the application whether it does need reliable service or it needs best effort delivery. If it does not need reliability, we can send it unreliably, but it will be delivered very quickly to the destination. But if it needs reliable service, we have to take some steps in order to make sure that the data is going to be delivered reliably. So that will be a different approach. So for both the services, we will have the protocols. We will take care of both reliable data delivery or best effort delivery on the transport layer. We will have the details of these protocols in the following lectures. What is a protocol in detail? When the human being, they talk with one another, they follow the human being communication rules and regulations that are called the human protocols. For example, if I'm going to ask you what is the time, so I have a question, okay, or introduction, I want to introduce myself, or you raise your hand to ask a question, or I'm going to put a question, what is the time right now? So specific messages are sent and specific actions are taken when messages are received or other events will occur. Okay. As I have given you an example that if you want to ask a question during the lecture, you have to raise your hand and the teacher will ask you, okay, what is your question? And then he will reply you. This is the human protocol while delivering the lecture in the class when the students are listening the lectures. Similarly, network devices, they would have followed the network protocol. They have to follow the network protocols. The machines over the network, over the internet, rather than the human beings. Now the end devices are not the people or human beings, they are the machines now. All the communication activity which will be taken place over the internet will be governed by these protocols. So now those machines will follow the network communication protocols in order to deliver their messages in between them. Protocols define particular formats, how the order of the messages will be followed when they are sent and received among the network devices, entities, hosts, and what actions should be taken on the messages when the transmission and the receipt of the messages are being taken place. So everything will be written in the definition of the protocol. That what will be the format of the message, how, in which order the message will be sent and received between the network or among the network entities, and what action should be taken when the messages are being transmitted and received. For example, when we talk about a protocol, what's a protocol here between two human being and between two computers when they are communicating over a network? This side will give the example of human protocol, and this side will give the example of a computer network protocol. She is Alice, he is Bob. Alice is asking hi, Bob is saying hi. Got the time? Bob said yes, 2 o'clock. Similarly, there are other human protocols. This is the timeline. Here this is a client computer, this is a server. In order to get a connection of the client with the server, a TCP connection request will be sent from the client to the server. A TCP connection response will be sent by the server to the client, and a connection will be established. In a three-way handshake, the client will acknowledge the TCP response of the server, and a connection will be established, and the URL will be pushed. Get this page from this URL, and the page, the file will be sent back to the client from the server. So three-way handshake along with a request and a reply. Request from the client to the server and a reply from server to the web server to the web client. So this client is using a web browser to establish a TCP connection with the web server. It has sent a TCP connection request, a TCP connection response from the server to the client, and acknowledgement of the response, connection response from client to the server along with the request to bring this page, and a page is brought from web server to the client. Clear? Network edge. End systems, the devices which are at the end of the network. Access, and these devices are located in the access network and are connected with the network through the links. A closer look at a network structure, these all are the end devices. Are these the end devices? Servers, laptops, desktop computers, desktop, laptop, your mobile devices. These are called the network edge devices. And you do run applications on these devices, on these hosts. These are the host running the applications. You do need access to the network. To get an access to the network, to the internet service provider network, you do need a physical media, a link, a communication link. So to get access to the network, you do need physical media, a communication link. This is a link, wireless link. This is a wireless link. This is a wired link, wired link, wired link of the access point with the router, and further wireless link, wired link, wired link, wired link, wireless link, wired link. So this link can be wired or wireless. It is called a communication link, either wired or wireless, with the help of a wire, optical fiber or copper cable, and wireless, either it could be a radio link or satellite link, Wi-Fi, WiMAX. Where this link will take you further? To the network core. This is the network core. This is the network core, the backbone of the network, from where you are being served on the internet. So the network core is basically so many routers which are interconnected with one another, and they form the network of so many networks, which is called the internet. Clear? The network edge. End system hosts, and they are running the application programs. For example, you are browsing the web in the web browsers, you are checking your emails using Skype, voice over IP, telephony service. All these applications are called the network applications, and these are being run at the edge of the network on the end systems or the host devices. So these are the end systems. In the client server model, the end systems, if they are the client, they will be served by the server. So these are the servers, these are the client machines. They need the services over the internet, so they have to send their request from the client to the server. This is called client server model. Client will send a request to the server, server will process the request and send the response back to the client. So client host requests and it receives the service back from the server, which is always on 24/7. Then only he can accept the request and can reply or send back the services or give the services or provide the services which are required by the clients. Example, web browsers are the web client applications, and they request the web pages from the web browsers, and their request goes to the web servers, and the web servers, they send them back the response in the form of web pages. Email client will contact with the email server or send their request to the email server, either to send an email to the other party, okay, or to pop, to retrieve, to get their emails from their mail boxes. So this is called email service based on the client server model. So you do need email client and email server. You do need a web client and a web server. And on the web client, the client application will run, and on the server application will run. On the email client computer, you will run the client side application, and on the server it will run the server side application. That is why it is called client server model, because the servers are listening the client requests all the time and available to serve the client's requests. This is another model which is peer-to-peer model, point-to-point model. It is minimal or no use of dedicated servers. You don't need a server. A client or a machine can have a connection with another machine. A mobile phone can have a connection with this peer. A peer-to-peer connection. This peer can have a connection with this peer. This is called a point-to-point connection. Definitely it will go through some communication channels or links. Example, Skype and BitTorrents. They are point-to-point connection. In the beginning, the Skype will follow the client-server model only in order to get the authentication. Okay, when you enter your username and password on the client application, okay, of a Skype, the request will go to the Skype server, because your username and password is stored on the Skype server to authenticate that you are a valid Skype user and your password is correct. Once you are connected with the server, you will get the list of the users who are online. You just click on any user with whom you want to have a communication, and once he replied you, a point-to-point connection will be established between the two users. Now whatever communication you will do, either you are chatting or voice communication or video communication or file transfer, it will be done peer-to-peer, point-to-point. So Skype is an internet application which is called a peer-to-peer application, but in the beginning it follows the client-server model. then later on only for authentication, then later on it follow the peer-to-peer model, direct communication between the two clients. Okay, definitely it will follow some route, some channel, and it will go through the communication links. Okay, similar is the case with the BitTorrent. Access networks and physical media, we will start our next lecture from here. So if there is any question till here, you can ask now.